Welcome to a world you wouldn't recognize. A time when the very air pulsed with unimaginable energy, a planet sculpted by forces we can barely comprehend today. When you think of a storm, you probably picture a hurricane or a tornado. But what if I told you that Earth's ancient history is filled with atmospheric giants that make our modern storms look like gentle breezes? We're talking about megastorms so powerful they could rival the scale of Jupiter's great red spots. This isn't just a weather report from the past. It's a journey back to a chaotic, beautiful, and utterly terrifying young Earth. A time when our planet was forged in the heart of a cosmic tempest. So, what ingredients does a planet need to cook up a storm of this magnitude? The recipe for cataclysm is surprisingly simple, yet overwhelmingly powerful. Think of a pressure cooker the size of a planet. You'd need a supercharged atmosphere, thick with greenhouse gases, trapping immense amounts of heat. Then, add a much faster planetary spin than we have today. Combine that with colossal planet-spanning oceans, and you have the perfect conditions for a hyperstorm. These are some of the same core ingredients that fuel the superstorms we see on gas giants like Jupiter. We'll dive deep into specific geological eras, like the Archean and Proterozoic eons, billions of years ago. During these times, Earth's atmosphere was completely different. There was little to no oxygen, but it was rich in methane and carbon dioxide. The continents were just beginning to form and move, creating a dramatic dance of land and sea. This constant continental drift drastically altered ocean currents, creating massive conveyor belts of superheated water. At the same time, immense volcanic activity was spewing unimaginable amounts of gas and dust into the sky, creating a thermal blanket that trapped solar energy with terrifying efficiency. Every single factor, from the planet's rotation to the chemical composition of its air, played a crucial role in brewing the ultimate tempest. These weren't just storms. They were planetary engines of chaos. Now, let's meet some of these legendary giants of the primeval skies. Imagine a hypercane, a theoretical storm so vast it could cover an entire continent. Its winds would scream at speeds exceeding 500 miles per hour, and its eye wall would stretch for thousands of miles. The air pressure at its center would be so low that the ocean surface would boil. The rain wouldn't be drops. It would be a solid wall of water. Drawing on advanced scientific models and geological evidence locked away in ancient rock formations, we can start to visualize the sheer scale and destructive power of these phenomena. We can see the scars they left on the early continents, carving vast canyons and shaping entire landscapes in a matter of days. And what about the lightning? We're not talking about your average thunderstorm. These were lightning storms of planetary scale, with bolts that could flash across hundreds of miles, powerful enough to ignite the methane-rich atmosphere itself. These events were more than just weather. They were fundamental geological forces, acting like a hammer and chisel on the face of the young Earth. They eroded mountains, created inland seas, and redistributed minerals and sediments across the globe, profoundly influencing the very course of life was just getting started on this violent world. So, how did anything survive? The question of life under this constant bombardment is one of the most fascinating parts of Earth's story. How did the earliest life forms, simple microbial mats and single-celled organisms, cling to existence? How did they survive? Or Rabin Tribe, amidst these ceaseless, planet-spanning onslaughts. This was a challenge far more profound than just enduring bad weather. It was about surviving in a world where the environment could be completely rewritten in an instant. The answer lies in incredible adaptation. Some early life may have developed strategies to endure these periods of extreme environmental stress. Perhaps they sought refuge deep underground or in hydrothermal vents on the ocean floor, shielded from the fury on the surface. Others might have evolved rapid life cycles, allowing them to reproduce and spread quickly in the brief calm between the storms. These megastorms likely caused massive extinction events, wiping out entire ecosystems. But in their wake, they also created new opportunities. The intense lightning could have synthesized complex organic molecules, providing a source of nutrients for life. The massive rainfall would have flushed minerals into the oceans, feeding the burgeoning ecosystems within them. So, in a strange way, these destructive forces may have also been a creative spark. We need to consider the long-term impact these megastorms had. They didn't just shape the land. They sculpted the very chemistry of our planet. They played a huge role in the evolution of Earth's atmosphere, oceans, and the composition of its surface, setting the stage for the more stable world we know today. The story of early life is a testament to resilience, a story of holding on against all odds in the face of Earth's ancient fury. So, are these ancient titans completely gone, or do echoes of their power still whisper in our modern world? While we'll likely never see a true hypercane again, the fundamental physics that drove them are still at play. When we look at the most powerful hurricanes and typhoons today, we're seeing a distant, much tamer relative of those primeval monsters. They are a faint reminder of the raw power that our planet is capable of. A power we still see in the giant storms on planets like Jupiter. Understanding these prehistoric storms isn't just an academic exercise. It gives us a crucial perspective on our own planet's climate system. By studying the extreme states Earth has been in before, scientists can build better models to predict and prepare for future extreme weather events. This is more important than ever as our current climate changes. We are, in a sense, artificially recreating some of the conditions of the ancient past by pumping greenhouse gases into the atmosphere. The lessons from Earth's chaotic youth serve as a stark warning. Let's end with a powerful thought. We live in a remarkably calm and stable geological era. It's easy to take this for granted. But the long violent history of our planet reminds us that beneath this tranquility lies an immense and ever-present potential for raw, untamed power. The Earth is not a static rug. It is a living, breathing, and sometimes furious system. Thanks for watching. If you found this journey into Earth's stormy past as fascinating as I did, make sure to like, subscribe, and hit that notification bell for more deep dives into the history of our amazing planet.